All right, hope everyone had a great long weekend. We're going to be discussing day 2 of hyperbolas. We're going to be mixing. We're going to be doing completing the square, and we're going to be doing given the characteristics, writing the equation as well. Okay, so there's a small difference between ellipses and hyperbolas, and that difference is this. If you look at both of these, with ellipses, both of those terms always were positive in front. With hyperbolas, one of them is going to be negative, because if you remember, our formula for hyperbolas are x minus h squared right? So that's one of them, right? And so whatever the negative sign is in front of, or to the left of, is always where b squared is going to be under. Okay, always where b squared is going to be under. Okay? So when we're doing completing the square here, okay, we have to factor out the negative every time for one, either the x squared or the y squared. So watch what I'm talking about here, okay? So when we do this, when I organize everything, first off here, I put the positive terms always first. I do x squared, and then I do the 6x because x squared and x, we keep those together, right? Okay? Same thing that happens with that negative 11. It's going to go over to the right. But now we're going to have negative 4y squared minus 8y equals 11. Okay? Now we're going to factor if we can. So leaves me with x squared plus 6x. Factor out the negative as well with that 4. That's the new difference here with hyperbolas. And it's going to be y squared now plus 2y equals 11. Now we're going to go ahead and take the b values of both the x and the y's there and divide them by 2. So 6 divided by 2 squared there gives me 3 squared, which equals 9. So because I didn't factor anything out of the x squared, I can automatically just go over here and add the 9. Okay. Now we're going to take that 2 divided by 2 there. So that gives me 2 divided by 2 gives me 1 squared just equals 1. Now remember, we factored out a negative 4 though. So we're going to do minus 4 times 1, negative 4 times 1 here. And so now when I do that, I'm going to have this. Remember our shortcut for factoring, 6 divided by 2 gave me 3, so I'm going to have x plus 3 to the second power minus 4 times 2 divided by 2 gave you a positive 1, so you're going to get y plus 1 to the second power equals 20 minus 4, so 16. And so now our last step is just like with ellipses, is to divide everything through by 16. And so my standard form is going to look like this. I'm going to get x plus 3 to the second power over 16, because that's just a 1 out front. Negative 4 divided by 16, that's going to give you this. It's going to give you y plus 1 to the second power over negative 4 over 16 is a negative 1/4. So we just write 4 there. And there you go. So there's my standard form right there. That is x plus 3 to the second power over 16 minus y plus 1 to the second power over 4 equals 1. So remember, for your center, you do opposite in here. Opposite, so our center is going to be at negative 3, 1. Okay? So now I'm going back up here, up top here, to come up with my a value. So remember, where is a squared at? Where's b squared? A squared is always under the positive fraction. Okay, so in this case, a squared doesn't always have to be bigger, guys, with hyperbolas. So then that means then that a is going to equal 4. Okay, that means b squared then is equal to 4. B equals 2. And then recall for c squared, we use this formula. Now it's a squared plus b squared, because the foci is outside of the vertices now. So that's going to give you c squared equals 16 plus 4, 20, And so then C equals square root of 20, which then that equals 2 root 5, which is approximated to be, calculator, sorry, real quick here. Got 4.5. Okay? So like what I like to do is I just go graph it, and then I can write out all my information, my vertices, my foci, all that stuff, okay? So let's go ahead and do that. And again, how I do my charts for the most part is I just go over 10, draw my y-axis, down 10, draw my x-axis. So our center, and I made a mistake there, should be -3, -1. My bad. Right there, so there's my center, so my vertices. So again, since a squared under x, this is a horizontal ellipse, that means my vertices are going to be to the left and right, so I'm just going to go left 4. Vertices, right 4. And one of those points, that looks like, 1, 2, 3, 4, 5, 6. So that looks like -7, -1 for one of the vertices. And then the other one, it looks to be 1, -1. Now our foci and our vertices are always on the same axis. So since our foci, since this is a horizontal major axis here, okay, our foci and vertices are going to be to the left and right of the center. So because we got a radical there, we're just going to write it like this. We're going to say -3 plus or minus 2 root 5, comma, -1. Because we're just going to add the 4.5 and subtract the 4.5 to get our points there. So I'm just going left 4.5. Right in that there, right 4.5. And there we go. So there's my foci. The only reason why we need the covertices is because it's just going to help us draw our box for our asymptotes, right? And so B is 2, so I'm going to go up 1, 2. CV down 1, 2. There's our CV, and now we start it and just drew our box through our CVs and our vertices. It's going to be rectangular. And the significance of this, guys, is that when you draw your box just through the corners of each box is where you draw your asymptotes through the center. Your slant asymptotes. Remember, it's a slant asymptote. It goes through the corner, through the center, and continues on. And that's what helps us shape it. And now all we do to draw the hyperbola part is we start at the vertices, and we just follow along the asymptotes. We don't ever go across the asymptotes. Don't ever go across. Okay, now how do we write the asymptotes? Okay, it's always going to be y minus k. So pretty much when you're writing the asymptotes, it's opposite. You keep, because it's y minus k and our center is -3, -1, it's going to look like this. We're going to get y plus 1 equals. Now how do we know when it's plus or minus a over b or b over a? Well, just ask yourself this from the center. Okay, how are you getting, what are you doing? Okay, if it's a horizontal ellipse, it's always going to be b over a, because we're going up b, then over a to get to the corner, right? Up b over a. So in this case, plus or minus b over a, well, b is 2, a is 4, right? So that's going to simplify to be 1 over 2, and then you just do opposite of h, which is x plus 3. If it was a vertical ellipse, we would go up A over B to get to the corner of the box. And so that's why you know it's A over B when it's vertical. Eccentricity has always been the same. It's just C over A. So that's 2 root 5 over 4, which then simplifies just to be root 5 over 2. All right, and there you go. So that is a completing the square Foley problem right there, okay? For hyperbolas. All right, and so I want you guys to do the other 2 for homework, and then I'm going to also do 1 characteristic. Okay? So let's go ahead and we'll look at number 5, okay? So transverse axis, that's the same thing as your major. Okay, and then when you see this down here, I'm sure I talked about this too. The conjugate axis is the same thing as your minor. Just so you know for when you're doing number 6. Okay, I just want to show you guys. Okay, so let's go ahead and look at number 5. Okay, so it says the length of the transverse axis is equal to 6 units. So remember, the major axis is equal to 2a, right? So that means I have 2a equals 6, a equals 3. So what do we need to know to write the equation of a hyperbola? We need to know whether it's a horizontal major axis or a vertical major axis. Okay? We need to know A and B, and we need to know our center. If I have all that information, I can go ahead, I can write my equation. So I've got A. I need to find B. We'll come up with that here shortly, okay? The only other thing it gave me was my foci. So let's go ahead and let's graph that. So we're going to go ahead and graph those and see what we got here. And we're going to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so it says foci are at 3, 2. So there's a foci, and then negative 7, 2. So what that tells me is since my foci are horizontal from each other, that means this is going to be a horizontal ellipse. I mean, not ellipse, sorry, hyperbola. Okay, horizontal hyperbola. Now, because we know where our foci are, we can also find our center because our center is equidistant to both foci. So let's count over and see how much total distance between the two. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have a total distance of 10. So we know the center then, what is half of 10 is 5. So just from this left foci here, or you go from the right, you're just going to count 5. So 1, 2, 3, 4, 5. So there's my center. So let's go ahead and let's write that down. So the center, and it looks like is equal to over 2 up to, so negative 2, 2. And then if A is 3, that means we know our vertices then as well. So A is 3. So that means we're going to go 1, 2, 3. Vertices, 1, 2, 3. Vertices. Again, because, guys, how do I know how to plot that again? Because the foci and the vertices are always on the same axes. Always on the same axes. Okay? So, what do I know? I don't know B yet. But do I know C? I do, right? Because C is the distance from the center to each foci, and they're going to be the same, and so that is 5. So now what we're going to do then is to find B, we're going to use our formula here. C squared equals A squared plus B squared. And so that's going to give me this. That's going to give me 25 equals Why is it 25? Because if C is 5, then 5 squared is 25, right? If A is 3, that means A squared then is 9. So then when you subtract the 9, you're left with this. You've got 16 equals B squared. So therefore we know then B is 4. Okay? So now we've got everything. We've got A and B, we've got our center, and we know it's a horizontal hyperbola. So that means my equation is going to be this. Opposite center, so it's going to be x plus 2 to the second power minus y to the second power equals 1. Again, why am I putting the minus sign in front of the y? Because when it's a horizontal hyperbola, x is always going to be positive. The x fraction is always going to be positive. If it was a vertical hyperbola, the y pattern would always be positive. Okay, the fraction would be positive. So that means then a squared is going under here. So if a is 3, a squared is 9. B is 4, so b squared is 16. Okay. And it tells me I don't have to technically go ahead and graph. It just wants me to write the equation. So there you go. We've got our equation, and we're done. All right? So really, really pay attention. Okay? All right? Pay attention to what it's asking you. These are great questions for the multiple choice test on Thursday. Okay? So keep up the good work. You guys are doing great. That is it for me today for the notes. I will talk to you in class tomorrow. Thank you. Bye.